minus 13. Nippy. Back again at the Fnirsi. I don't really know how to pronounce it, guys. My apologies if I'm butchering it to the manufacturer. Yeah, back at the little DSO 152 and carrying on with our fundamentals, you know, trying to just understand what the hell is going on, keeping it simple, keeping it basic, trying to keep the geek terminology to a minimum, but it's the nature of the beast. You have to deal with some of it, right? Which is fine. Okay, so today detail is going to be focusing on the trigger, guys, right? So there's kind of three fundamental of fundamentals aspects of a scope that you need to thoroughly understand in order to be able to use it even kind of a basic level. Probably the trigger, which we're discussing today, is the least of those basics that you really need to understand, in the sense that if you keep it in auto, that is one of the trigger modes. You can actually have, you'll always have some kind of image on screen, although in certain scenarios it'll certainly be less than optimum. And again, that's the point to today's material. So there's three modes of operation, three trigger modes that you can use on the DSO 152. Most other scopes have similar modes, usually 2 or 3 modes, basic triggering modes. And this is all internal triggering. With a $20 scope, of course, you don't expect anything fancy like external triggering. That's beyond the scope of this discussion. So the three trigger modes, and how do you select them? Well, the mode button, right, comes in handy for switching triggering modes. That's its fundamental purpose, really, although it has other purposes. So up in the top left-hand corner, keep an eye there, guys. At the moment, I'm in auto. I'm just going to show you the modes that are available. There's normal, and there is single. You might have noticed when I selected single, all of a sudden we toggled from run mode to stop mode, right? Mode of operation. So let me just go back to auto here. I'll hit run again, and you might notice that the trace came live again. So what I'm going to do is I'm going to long hold the run button, and it will bring up the parameters again, if you recall. So sometimes simplification is, most times, simplification in a machine is fantastic, right? Other times, perhaps it goes too far. You might remember the old engineering adage that says a machine should be simple as it can be, but no simpler. Maybe they took this a wee bit too far, in my opinion, with respect to the trigger, but the parameters that I just brought up, you can see they're essentially live now, right? You can see they're updating quickly, right? That's because the trace is triggering in an auto mode of operation. Now, I know I haven't explained what triggering means yet, but I'm getting there. So having the parameters up, although sometimes you may not even need them, I suggest you keep them up on screen if possible, for the simple reason it lets you know that you won't find this in the manual, but the machine is triggering. The scope is triggering on the trace that you actually have in front of you. And again, I'll explain that in a wee bit more detail as we get to it. So in auto mode, if you select the auto button, and I've told you to steer clear of that for learning purposes in the previous module, use it at your discretion, guys, but I think you get the point. For initial learning, it's good to try and steer clear of the auto functions so that you can actually manually control the settings. And if you can manually control the settings, you tend to have a better understanding for what's actually going on. So typically, auto triggering usually occurs at 50% of the waveform height, waveform amplitude, right? So with respect to the y-axis, this is the triggering icon, okay? Symbol. Sometimes it's a diamond, sometimes it's a cross. In the case of the DSO 152 here, is a little arrow. We have no horizontal trigger. Some scopes do. You can actually position a horizontal trigger as well as a vertical, meaning Y and X. And it allows you to actually set where the trigger actually happens, not only with respect to the amplitude, but also with respect to the time base. This only allows you to do so with respect to the amplitude, okay? So keep that in mind. So when you're adjusting the trigger, and you can do so, right? Let me show you here. So again, in auto, it will select 50%, it will default to 50% of the amplitude of the signal you're looking at, but you can adjust it. And let's do so because it makes the point. Okay, so keep in mind, if you see the numbers updating, it is triggering. So let me move the trigger marker itself out of the way of the trace, and you can see what happens right away. Well, that's less than ideal, right? We've got the trace actually walking across the screen now, and it's difficult to appreciate what's actually happening, right? This is the whole point to the trigger, guys. Let me bring it back in a range here. So now you can see that I'm well within. It doesn't really matter where with respect to this simple demonstration because we have a symmetrical pulse here, but sometimes it's an erratic trace that you're looking at, perhaps a fuel injector or ignition trace, for example. It's quite a radically asymmetrical pulse that you're looking at, and there will be optimum spots on a trace that you should choose, and actually in order to keep the image as stable as possible. For here, it doesn't really matter so long as we're not at the extremes. So at the 2/3 mark here of the pulse, so long as the amplitude of the signal crosses this threshold, this vertical threshold, or this amplitude or voltage if you prefer, the machine will trigger, meaning it will snap that image and then redraw the image at its next frame over top of the previous one. And now the machine basically has a reference point in order to redraw it. If the trigger or threshold is outside of that limit, it doesn't have a reference point, and hence the trace is actually walking across the screen. I hope that makes sense. Now keep in mind, the machine is still triggering. You can see it's updating here. It's triggering all the time in the auto mode, but has no actual fixed reference point on the trace in order to stabilize the trace. So again, let's bring that back down. There's one other facet I want to mention here about the trigger, guys. See this little icon here? This little symbol? This can be used in two modes of operation. Now, when I change this, keep an eye on the trace at the same time. If you toggle a quick press, actually just changes the basic mode of the trigger, auto, normal, single. But if you long press the mode switch, it changes from rising, which it was previously, to the falling edge. So you'll notice here that when we cross this point here on the trace, again, that's where we've set the trigger manually, just randomly pretty much, and crosses this point on the screen, you'll notice that the image actually changed there with respect to when it started to paint the image or the trace on the screen. Let me just change that again so you can appreciate what I'm saying. Long press on the mode. Now we've gone to the rising edge, so it's triggering on the rising edge of the pulse here, and that's why it starts to draw on the rising edge as opposed to the falling edge. Does that make sense? I hope that makes sense, guys. Again, we're in the same mode. We've just changed from the rising edge mode to the falling edge. Right. So again, that's the auto mode of triggering. Less than ideal because sometimes, because you'll have an asymmetric waveform, the trigger point can actually be unstable, and you'll still get a walking image on screen. By the way, I should have mentioned, guys, I'm just using, again, the internal signal generator that the little rig has, the capacity to generate signal, 1000 hertz. and you can see all the parameters there with respect to its amplitude. So I'm just using the internal signal generation for the sake of the demonstration, just to keep it simple so you can do the same thing if you have the same machine or something similar. Right, let's go to the next mode with respect to trigger. I'm just going to hold that long so we go back to the leading edge, right? And you can see, well, you think, well, nothing happened, like there's no change. No, what's the difference, effective difference between normal and auto? Let me just go back to auto for just a moment because I should have made this point. Back to run, auto. So I'm going to lift this. Let me bring this in frame here so you can see. So I've lifted the contact off the test point there, guys, and you can see that the trace dropped to 0, right? We go back, you can see it comes back, and you can get an idea that it drops to 0 when I've lifted the contact, right? Let me go back on here. Again, let me change the mode back to normal. Sorry, that was a long press, that was my fault. Another long press, change it back. Okay, so what the normal does is it will draw and hold the image on screen. So sometimes you'll have a pulse train that only appears momentarily and then is gone for, you know, a relatively long space of time relative to how long it's on screen for, is what I mean, right? So in the case of that, it would be nice if you can actually hold the trace on screen. Now, of course, you could hit the run stop. You could stop it and hold it on screen indefinitely. But sometimes this little waveform here may only be on screen for a couple of milli or microseconds, in which case you're not going to be quick enough with a button. Make sense? So let's go back to run mode here. Again, look at the parameters. You can tell it's triggering, guys, because the parameters are updating. Now, let me just bring this into screen so you can see it, into frame so you can see it. I'm going to lift the contact off. So there is no input into the BNC cable there now, guys, right? There is no signal present on the line, and yet we have this image presenting itself. This is really important to understand the distinction between auto and normal. And you think, well, I much prefer auto. If that's the case, you're clearer on what's going on. In some cases, that's true. But again, in some cases, you want to hold the image that's in front of you. Again, there is no, some scopes have a triggered or wait icon. Some of the other scopes that I own. So it's telling you whether it's waiting or whether it's actually been triggered. This scope, being a simplified format, doesn't have that. However, you can actually go through the side door here with the parameters, and you can see that they're not updating. This should be cueing you to the fact that the machine is not triggering, meaning this is a held image. It's not real time. It is a held image because of the mode of operation that you're actually in. That's the main distinction between auto and normal. And again, you might think, initially, I suggest that new users, I'm still relatively new to scopes, guys. I've only got a couple of years exposure to them. You know, the new users stick to the auto mode for at least the meantime, and then start experimenting and understanding the benefit of selecting an alternative trigger mode, especially normal. It will hold, freeze the image for you automatically. And now let me bring it back into frame again here so you can see. And as soon as the signal reappears, you can see the parameters are updating again there. Now this is a real-time trace. This is updating in real time. It's no longer a held image in the sense that is a frozen, a freeze frame. Yes, the image is being held with respect to the pulse train, not walking across the screen. I'm trying to make a distinction between the two here, guys, because they're two very different things. It is updating in real time. And again, there is no triggered or wait icon on screen, but you can tell that is the case because the parameters are updating. Okay, so I hope that makes sense. That's the distinction between normal and auto. Although they look similar, they're two very different things, and you need to be keenly aware of the distinction between the two. Right. So, let's go to the last mode of operation here, which is single. Sorry, that was a long press again. I'll get it right here. Fumbling with the buttons here, embarrassing myself. Okay. So you can see here, guys, what I've done is I've transitioned from normal to single mode of operation now. Yes, admittedly with some fumbling in between. So what's the difference here? Well, here you can see we have nothing on screen, keeping in mind that I am disconnected at the moment here, guys, to make the point. What the single mode of operation does, some scopes will call it one shot or single, as this one does, single shot. What this one does is, as soon as the scope sees a trace, any signal that crosses the threshold here, and in this case, it is a rising edge, right? So as soon as the signal crosses the line, it will draw and hold the image, what it actually captures, and not update to the next frame. Only the initial occurrence of the crossing of the threshold. And again, you can define that by either a rising edge or a falling edge. That makes a huge difference. I'll get back to that in just a second. So again, let me just momentarily touch. I'm just going to momentarily touch, and also note the run mode there, guys, right? What it currently is in run, the scope. I'm just going to momentarily touch the signal generator test point there. And the scope has seen a voltage or an amplitude input that has crossed the threshold and now stopped the frame from capturing any further, because this is what you've actually asked for. It stops the mode of operation. You can see that the parameters are no longer updating, but unlike the normal mode where it's waiting for the next one, now it's not waiting for the next one at all. Watch, I can touch I'll touch the contact here, guys, and it won't change. And it should be obvious to you why it won't change, because we've transitioned from run to stop. So this mode of operation is excellent if you're interested in capturing a glitch of some sort or a transition of some sort that might be perfectly normal, but you want to catch it. Like starting your car, for example. There's a massive amount of current draw when the starter first starts to rotate, and first has to overcome its own inertia in addition to the inertia of a stopped engine. The current draw is massive. Now, sometimes you want to see that, in which case you could set the scope up in a similar fashion here. You'd see the current go up. If you had a current probe adapter, right, not in this setup, but in a current probe adapter, you could see the current go up, and then as it comes down, it would freeze just that image, and you can get an idea of the start current draw, for example. Just an example, guys, right? Now, maybe you don't have a current clamp, in which case you could go to the mode, a long hold. I'm just going to get rid of that image on there because it's no pertinent to what I'm trying to explain. If you just use the battery voltage usually acts inversely to the current draw upon it, right? So if you have a massive current draw of 200, 300, 400 amps from your starter, the voltage would go down, in which case you could monitor the battery voltage up here, set the trigger point to just below whatever you think the battery will drop to, and as the battery drops, it will catch that image. So keep in mind, you have to cross the threshold that the trigger has set in the direction you have set. Again, you could have a voltage up here all day long, but unless it drops below this amplitude or voltage level, you're not going to get the image. These are important distinctions that you have to make. So, as I was saying, initially, guys, stick to the auto mode of operation with respect to the trigger. It will always give you an image, and it's quite intuitive what's going on. Less so with the normal mode, and less so with the single mode. Also note, one thing I should have showed you guys is if you're going to adjust the channel marker, that as you might expect, the trigger marker will actually transition as well, right? It keeps in sync relative to the channel marker. Again, I hope that makes sense. Auto, short press to change modes, normal and single, and that's your options with respect to the trigger. Keep in mind you also have an option with respect to the rising or falling edge. It's critically important you understand the difference between all those modes, guys, because you could be looking at an image like this, not really thinking it through, and think, yeah, I'm good to go, I've got my trace there. You know, my sensor is putting out its pulse, tracking the cam or crank rotation, and in reality you've got nothing. So be clear, understand the distinctions between those modes. And again, I understand initially as a new user you're less inclined to think the trigger is that important. Believe me, it's extremely important. I'll leave it at that. This has run a wee bit longer than I was expecting, guys. Okay, that's it for now.